G'day, how you going? In this video today we're going to look at doing a derivation of a generic formula. Now you might use this if you're say designing a game. This would allow you to have any input cells, and so if you've got a generic formula, if you have those input cells you can then get the projectile to do what it needs to do. Anyway, let's start. So what we're going to do, you need to know this derivation to find the range, and you should better find in this form here. So let's go through that. So initially, if we're starting over here, we know that the V, I need to get to my drawing, the V vertical is going to be equal to V sine theta. Okay, and we know the V horizontal is equal to V cosine theta. Alright, so they're the two things that you do know at this stage. Alright, so the next thing that we need to have a go at doing is looking at the time of flight. So for the time of flight we know that SV is equal to VVT plus a half of AVT squared. Alright, so when we know that, now we're going to be looking at a situation where it goes from ground to ground. We know that our SV is going to be 0. We know that our VV is going to be simply V sine theta, putting it in there, T, plus a half of gravity. That's what acceleration is, and then T squared. Now we're going to solve that. I'm going to bring a common factor of T out, and that will leave us with V sine theta plus a half GT. Now rearranging that says that T is equal to 0, or it's equal to, now bring that across, that's minus V sine theta all over a half of G, which you also could write as simply minus 2V sine theta over G. Alright, it's probably a better way of writing it, getting rid of the fractions. Alright, so now we have our time of flight. The next thing that we would do is to use to work out our SH. So our SH is going to be equal to our VH times our time of flight. Now obviously we're not going to use the 0, we're going to use the time when it hits the ground again. So that's going to be, VH is going to be V cosine theta, and then that's going to be times by our time of flight, which is minus 2V sine theta all over G. Combining that gives us, now we've got the 2 and the V, so that's going to give us 2 minus 2V squared cosine theta sine theta all over G. Now in maths there is a relationship. We know that 2 sine theta cosine theta is actually equal to 2, not 2, it's actually equal to simply sine 2 theta. Alright, that's a relationship there. So what it means is we can replace the information in our formula here. So where we see our 2, we've got our 2 there, we've got our cosine theta and our sine theta. So therefore what it allows us to then do is to then write our final thing, which is SH, or our range, is equal to simply V squared, and it's minus V squared, sine of 2 theta all over G. And so that's a relationship we're trying to prove. Alright? Now, the key thing about any derivation or proof is that you need to know how to do this from scratch by yourself. I suggest that you watch this video maybe. Don't write any notes down, have a go at the derivation. Can't quite remember it, then come back to the video and do that again. Alright, so you've got to keep doing that. Now, in the next little video that I'm going to show you in part 2, task 2, is to design a spreadsheet that allows you to track the motion or show the motion of a projectile. So we'll go through that in the next video.